In this lesson, we're going to talk about the algebra and composition of functions. And a lot of this is combining like terms and multiplying and doing various things that you've already done, but we're going to do it with multiple functions. We're going to talk about addition, subtraction, multiplication, and division first, and you have to find the domains of each of these. Addition and subtraction and multiplication are probably the easiest ones to do. Division is still fairly easy, but it does have a little bit more involved when it comes to your domain. With addition, so we have f plus g of x. If we were to write this in another form, that might make more sense. What this means is we're going to take f of x plus g of x. That means I'm going to take this x plus 4 plus x squared minus 2. And then I combine like terms and write it in standard form, which is highest exponent to lowest exponent. So f plus g of x, this is going to equal x squared plus x plus 2. And we'll come back to our domain in a second. Subtraction is going to be very similar, except for instead of addition, it's subtraction. So I will do x plus 4 minus x squared minus 2. If you wanted to, you could change some signs around here to make this a little bit easier. This is the whole keep, change thing. So if we make that a positive, that changes all the signs in this parenthesis. And then it's just an addition problem again. Combine like terms, write it in standard form. So f minus g of x is going to equal a negative x squared plus x plus 6. Multiplication is also similar, except for instead of adding or subtracting, we're multiplying. So we will have x plus 4 times x squared minus 2. This involves the distributive property, or foiling if you prefer that term, where we take these multiplied, these multiplied, these, and these. So the first one would be x cubed minus 2x plus 4x squared minus 8. And then we want to write our answer in standard form. Remember, our standard form is highest exponent to lowest. So x cubed plus 4x squared minus 2x minus 8. All right, division can actually be super easy if it works. We're going to take f of x divided by g of x. That means we're going to have x plus 4 divided by x squared minus 2. The first thing we check is, could either of these be factored? If they can be factored, we want to factor them and see if anything cancels. Well, x squared minus 2 does not factor nicely. X plus 4 is already simplest form, so this is actually our answer for this one. So if I were to ungroup these here, let's see if I can get this to be, there we go. So all the red ones are our answers here. The next thing we have to do is go through and find the domain of each of these. What I'm going to do to find those domains is I'm going to number these. So this one is 1, 2, 3, and 4. 1, 2, and 3 are all polynomial functions. So 1, 2, and 3. So all of those will have a domain that is all reals, or negative infinity to infinity. 4 is where it gets a little bit different, because on 4, it is not a polynomial function. We have a fraction here. So we have to use our domain rules to do that. And our domain rules say, if there's a fraction, take that denominator and set it not equal to 0. So then we end up with x squared does not equal 2, x does not equal plus or minus square root 2. So our domain for number 4 is going to be, let's get my arrows arrow drawn. All right, so we are negative infinity to negative square root 2, or negative square root 2 to positive square root 2. Ooh, that's a terrible square root. Or square root 2 to infinity. Typically, this is how it works, is our 1, 2, and 3 will have the same domains, and 4 will have a different one. That's not always the case, but most of the time that would be the case. Let's look at another example. So how do we think this will work? Well, hopefully you can see that things might work out actually a little bit easier on this one, but let's kind of wait and find out here. Addition, once again, means I'm taking this x minus 1 square root plus x plus 4. So let's just write that out. So x minus 1 plus x plus 4. Here's the problem. When it's inside a square root, it cannot combine with things outside of a square root. So this right here is your answer. Subtraction is going to be very similar. The only thing you have to be careful of, and I should have said you could put these in parentheses, it's not that important except for on subtraction and on multiplication. Because this negative is going to distribute. So this one will actually be x minus 1, still all under the square root, minus x minus 4. All right, what about multiplication? Well, once again, f of x times g of x. I cannot distribute this into a root, so I really can't do anything with it. The only thing I'm going to do is maybe put my non-root piece out front, just because that's a little bit nicer to look at that way, but even that's not a huge deal. So far I've got all my answers here. Now let's try division. So f of x divided by g of x. This is where it gets a little bit trickier. All right, so I've got the square root of x minus 1 over x plus 4. Can't simplify anything. So really with square roots, all of these operations are pretty easy. It's the domains that can cause us some issues. So let's talk about the first three here. The only thing that's in those is the root. And if you remember when we were talking about domain rules and your roots, you set what is inside the root greater than or equal to 0. That means x has to be greater than or equal to 1. So I'm going to do it this way. So addition, subtraction, and multiplication all have a domain that says x is an element of, and we start at 1 and go to infinity. This division will cause some problems. We still have this root, so we still have this right here. But we also have this denominator. So we'd say, okay, with our denominator, x plus 4 cannot equal 0. So x cannot equal negative 4. Let's sketch this on a number line. Okay, here's 0, here's negative 4, and here's 1. All right, with this, we do the inequality first because that kind of narrows it down by a lot. All this is saying is x has to be greater than or equal to this. But over here it says x cannot be negative 4, which is this over here. So there's an open circle here, which is fine because we can't be over here anyway according to this. In this case, all of our domains are all the same because this negative 4 is not part of that original one, so it really doesn't make a difference. So that's adding, subtracting, multiplying, and dividing. The next part is the composition of functions. This one gets a little bit trickier while you're trying to figure this out. What we have here, it looks like fog and goth, but really how you say this is F composite G and G composite F. Another way to write this might be F of G of X. this one would be g of f of x. That means on this one here, our g of x, so this equation right here replaces all the x's in our f. So for our very first one, we're going to take this right here and replace, all right, hold on, all the x's, which in this case is just one. We're going to replace that x and put it in there. So I'm going to have an x squared minus 9 and then a plus 4. So this used to be our x, and now it's this equation. So if I were to go through and actually simplify that, those parentheses aren't actually doing anything. So I'm going to have an x squared, negative 9 and positive 4, be a negative 5. So how do you think this one's going to work down here? Hopefully you said, well, since f of x is inside the g of x, I'm going to take this and plug it into the x over here. And if you said that, that is correct. Which means I'm going to have an x plus 4 inside the square and then a minus 9. If you had multiple x's, you would plug it in multiple times. If you had multiple x's, you would also probably want to FOIL this out. This does not mean distribute. This right here does mean x plus 4 times x plus 4, which is that multiplication we did on the last problem. So you would distribute. If you were to distribute this, you would have x squared plus 8x, and then 4 times 4 is 16, minus 9 would be a plus 7. So all distributed out, this would be our answer. The other thing we have to do is find the domains of each of these. Well, both of them are polynomial functions. That makes life a lot easier because our domain of all polynomial functions is negative infinity to infinity. So that means our domain for both of these would be negative infinity to infinity. Oops, sorry about those infinity signs.